Presidio can redact every entity it detects. The leak is the entity its recognizers never found. You'll learn how to measure entity-level precision, recall, and F1 with Presidio on labeled cases and block logging whenever recall misses PII. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. A log line can look harmless after redaction and still contain a customer email, a name, or an internal identifier. That is the dangerous failure mode. Redaction only protects what the detector finds, and a detector can miss formats it was never taught to recognize. Presidio is a good fit because it separates detection from anonymization. You can inspect what it found before changing the text. Building that inspection yourself means managing patterns, offsets, entity types, and language details from scratch. A simple check asks whether any sensitive text was removed. A better check asks whether every labeled sensitive span was found at the right location. If one expected entity is missing, recall drops, even when every detection that did occur was correct. We will build a small test harness around realistic request text. It starts with one email, grows into labeled adversarial cases, measures detection quality, and finally prevents unsafe text from reaching logs. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. We begin by proving that Presidio can find one known kind of sensitive value. This snippet runs a focused Presidio scan on one request containing an email address. Successful redaction begins with detection, so the code creates an AnalyzerEngine and limits analyze to email address for a clear baseline. Each item in hits contains the detected entity type and its character span, which later lets us compare Presidio against labeled expectations. Restricting entities can reduce unnecessary recognizer work when the required PII categories are already known. The output confirms one email address detection, establishing the smallest working check before building a repeatable evaluation. One clean example is useful, but it cannot reveal the formats your detector misses. This example converts readable adversarial cases into exact entity-level labels. A redaction test needs ground truth beyond whether the final text merely looks cleaner, because an untouched identifier can otherwise pass unnoticed. Each case stores its text, expected type, and sensitive value. Gold then records the case index, type, start, and end offsets. This format mirrors prompt experiment inputs containing contact details, names, and internal run identifiers, while remaining easy to inspect. The output verifies that all four cases produced one labeled entity, giving the Presidio evaluation a reproducible target. Now that expected spans are explicit, we can compare them with what the analyzer actually returns. This code measures whether Presidio finds the right entity type at the exact labeled span. A pipeline can redact every detected result, yet still leak PII, so Pred captures AnalyzerEngine.analyze results across the full test set. Set intersections count true positives, while unmatched predictions and labels become false positives and false negatives. Precision measures how often detections are correct. Recall measures how much labeled PII was found, and F1 balances both. The output exposes perfect precision, but incomplete recall, showing that one labeled entity would still reach logging unchanged. For more practical lessons on Python, AI engineering, and LLM systems, please subscribe. The missed label tells us where to improve, so the next change teaches Presidio the format it does not yet understand. This snippet extends Presidio with a pattern recognizer for the identifier missed by the baseline. Built-in recognizers cannot know every organization-specific format, so pattern defines the expected EXP code and assigns it the experiment ID type. Analyzer.registry.addRecognizer makes that detector available to later AnalyzerEngine.annotate calls without replacing Presidio's existing recognizers. The test set is rerun into tuned, and new recall is compared directly with the earlier recall, so the change is measurable rather than anecdotal. The output shows the added recognizer closes the observed recall gap on this labeled set. A higher score matters only if it changes the decision at the logging boundary. This example turns the evaluation into a small logging safety gate. Raw requests should not be admitted merely because anonymization ran. So AnalyzerEngine.analyze first produces spans, and AnonymizerEngine.anonymize replaces every detected value. Safe logs contains only transforms text, while missed checks whether any exact gold entity remains absent from tuned. Gate blocks the tested pipeline whenever recall is incomplete. Precision should still be monitored separately because excessive detections can remove useful content. The output shows a passing gate and a safe log where Presidio replaced the email before logging. When a team adds new prompt templates, support forms, or product identifiers, this labeled set should grow with them. Generic recognizers handle common PII well, while custom pattern recognizer rules are preferable for stable internal formats. For loose or changing formats, collect examples first and test carefully before trusting a broad pattern. This example shows why redaction testing is not just about whether transform text looks safe. Exact entity-level recall catches the span that a visual spot check can miss. A passing test set is evidence, not a guarantee, so keep adding cases from safe, reviewed failure examples. Try adding another realistic identifier format to the same cases. Then watch whether recall changes before and after a recognizer update. You can also tighten a custom pattern if it starts matching ordinary text. What practical privacy testing topic would you like to explore next? Leave it in the comments and subscribe for more clear Python lessons.